Welcome to our first ever dedicated industry forum for energy and utilities. Let me hear it. Come on. It's been a long time coming, but as some of you must have seen in your announcements and all the spam we sent to you, is we focused for the first time at Databricks in our existence as a company, announced data intelligence platform for energy earlier this year, pretty much 6 weeks ago to this day, and it's been a resounding success, right? From our perspective, we're getting closer and closer to solving every customer in this industry's highest value pain points, because that's where AI can unlock tremendous amounts of value in solving the most complex challenges in oil and gas exploration, renewable energy, energy transition, decarbonization, all of the existential issues facing our planet today. So I'm super excited. This session is not about me, though. This session is not about Databricks in its current raw form, per se. This session is about customers and partners who are doing game-changing work using the power of the platform and applying it to real-world challenges in the energy industry. So without further ado, I'm going to introduce the Xcel Energy team here on stage who are going to walk through the amazing work they're doing in their work.
Hello, everyone. Glad to see you all here. Excited to be on stage here with Xcel Energy. My name is Giacomo Listi. I work with Nousot, and I'm the practice leader for energy and utilities. I'd like to hand off to Tom.
Good afternoon, everyone. My name is Tom Moore. I'm the technology, analytics, and artificial intelligence leader at Xcel Energy.
And I'm Cindy Hoffman with Xcel Energy. I lead our data science and data governance practice and work hand in hand with Tom and Giacomo as we've gone through our modernization journey.
Great. So, go ahead, Tom.
All right, so to start out, a little history of how we are here today as Xcel Energy with Databricks and Nousot. So a little bit of background for everyone. Xcel Energy, and probably not unusual for a lot of the different utility companies, sometimes we're slow to roll. So we find a tech that we want, it takes a long time to get that tech in, and our history is that we've not had great behavior in buying tech and then properly implementing that technology. And so we acquired a lot of tech debt over the years and a lot of maybe not so great decisions that we've made over time that didn't enable our users and our communities. A common theme that I've heard in my short tenure, so I've been at Xcel for 1.5 years now, but in my short time, I've heard a lot of stories of, sure, it's what I've asked for, but it's not what I need. And so very ambitiously, about 1.5 years or so ago, Xcel took the plunge with Databricks. We started a POC with Databricks, and very well intended, and it sat for 1 year. And we didn't do really anything. Didn't build enterprise patterns, didn't do any kind of strategy, didn't engage our business. And it was, we hit a crossroad. And during that crossroad, we got a knock on the door from Nousot. Nousot is a vendor that we work with. We'll talk a bit about some of the other cool things that they've done with us over the last 1.5 years, but they really helped us game change. So we went from a lot of different siloed solutions, a lot of old tech, a lot of really difficult ways to get to your insights to you're going to hear some really, really great innovative use cases that we've been playing with in the last year and some excellent progress. I would say we've done a complete 180. And it's changing how we interact with our business has been very transformational.
So what you have here is kind of a timeline of some of the use cases that we've done. We've been on this journey with Xcel for 2 years and have accomplished a lot. The elevator pitch at Nousot is we like to come in, advise, modernize, and enable. And what we want to illustrate here is how we truly did that. We want to come in and advise with clients and really form a partnership. And to do that, we have to get to that enablement step. And how do you do that? Well, when we do modernization use cases, we're working side by side with their team. They're integrated in the team. We'll do the pair programming, 2 in a box. So along the journey, we are upskilling them, modernizing them, and truly enabling them so that they can continue on without us. So one of the themes you'll see here is when they established Databricks install, they came up with the strategy of the unified data platform, very well aligned with your enterprise strategy, referred to as the UDP. So you might hear that term mentioned here, with all the great intentions. And so, we started off and we were able to do an assessment originally to understand the UDP goals. But as most companies, they create a strategy, looks great on paper, not always the easiest to execute. You have to look at the way they work, look at the analytics maturity, and really what is your target state. So we'll start talking through some use cases here and kind of tell you how we got down that journey. And I'll turn over to Cindy.
So the first one we'll expand upon was driven out of our need to comply with the Colorado Consumer Privacy Act. I know a lot of different states are enacting privacy laws. We had talked about the need to have lineage and cataloging and all of those capabilities, but until we had something that kind of forced our hand, that was kind of our plunge in. So what we did was used the platform not only to just do the cataloging and lineage, and I'll explain to that in a bit more in a moment, but we had a lot of customer data spread across a lot of different warehouses, a lot of different applications. We didn't have good handle on where it all was, and if we had to comply, whether it was to provide a customer what data we had on them, or if they asked for it to be deleted, cleaned, whatever it might have been, we needed a better way to find the data. So we built a language model, leveraged that opportunity to go across all of our applications, look at the tables and the schemas, the fields, to figure out where was the data that would need to be targeted to comply. So that language model took out an immense amount of time that we didn't have from our business partners to work with, and we didn't have documentation to rely back and fall back on. So that one alone was a huge time saver, and that kind of opened the door to the next one, which was, like I said, the data governance process. We didn't have, I would say, tools and processes in place from a data governance perspective holistically. We had frameworks from a roles and ownership perspective, but if you don't have the tools to actually do that work, it makes it very hard to have people be held accountable. So the next stage was really around when we had Databricks in place, expanding its use, making sure that we could have the lineage, the cataloging. So as we have data being coming and ingested for different use cases, making sure that we had that as a preferred path. In order for you to bring data in, you have to assign ownership so we can have maintenance and have scheduled checks and balances, I would say, more than anything, to make sure that we knew that what we were using and what was going to be built into the data products was going to be reusable and of quality, so that we didn't end up with just a lot of data that people couldn't find. The finding and accessibility of our data across the platforms was extremely hard in our prior life. So this was just a transition into that.
Yeah, part of that, Cindy, you guys established a Purdue model.
We did. Yep.
Where they're able to describe, define data product owners, and then when we're ingesting data into the platform, there's a preferred, acceptable, discouraged, and unacceptable pattern where, we want to get quality data in a platform, get it in the Unity catalog, make it discoverable to the users who then, create that self-service enablement of analytics. Another project we did was an MLOps Kickstarter. Cindy's team, the data science team, they have some very talented data scientists that like to create models. And we needed to help, modernize them. So we helped basically get their model development on Databricks. And with that, to help them be more efficient, we were able to set up MLOps templates, get them set up with Git, CI/CD, and be able to just operationalize that very standard practices.
I would say that the previous model that we had, or the process that we had, was really slow, very inefficient. And even though as we worked through putting the MLOps processes in place here, there was, just from an awareness, there was a couple iterations we had to go through just to get the security to schema mapping right, because we were going off of 1 or 2 use cases that we were kind of building around. And then when we started applying that process to some of the other ones, we figured out that we had to make some adjustments. So I don't want to make it sound like it was just like you throw it in and it's everything is perfect. There's definitely has been iterations as we've worked through this process.
Data scientists can spend more time working on models versus messing with automation.
Got a couple of them in the room, and they're very happy to have this in place.
Next was, it's one of our brick builders, our data intelligence platform accelerator. This is where we, once again, look at the enterprise strategy, look at the way they operate, look at a target state of how best to utilize the best capabilities of the data intelligence platform, do that gap analysis. And then we build a suite of enablement products to automate the onboarding of the business users onto the platform. So this is IAC infrastructure as code, cluster management, security management, provisioning, data ingestion patterns, so they can have faster time to insights, and they're not that was taking them about 6 weeks to get onboarded to where they can actually do some analytic use cases. We got it down to the days. So from a way to be more productive, this was monumental in kind of creating that plumbing so that they don't have to worry about it. So then the first after we set up that plumbing to kind of automate it, we had to realize, is this really automating it? So one of the first use cases was the smart meter data lake. So they have about 4 million meters where they ingest daily, or hourly actually, into Databricks. And it's going into meter data lake. And from there, they're doing grid visualization to understand the health of all the meters. And they're doing anomaly detection models to understand if anything's going wrong. So we were able to get them onboarded and get more productive, with IAC. And that was a great use case there with the scale of data that's flowing into the system.
Piggybacking off of that, one of the use cases where we use that lower level granularity of data, when we think now down to the feeder level from meters, we've got our load forecasting team and our demand forecasting team that feeds into our long range resource plans. Currently, we are able to run that maybe once a year, and it's not something that has end-to-end connectivity and transparency and auditability. So when you think about from a utility perspective, we've got regulators that we have to make sure that we can explain our needs and how we're going to meet the upcoming demand, especially with some of this, like we operate in 8 states. A couple of our service territories are being looked at very heavily for like data center expansion. So the growth that we are seeing on our system is huge. So us to be able to forecast that is necessary. Having Databricks and having this lower level of granularity, the compute power, the ability to like churn through that has been amazing. We're about, I don't know, give or take 3 months into that project right now. And we started as a proof of concept just to say, will this actually work? And we're proving it out. It will work. We're going to have our distribution forecasts that feed into our load forecasting, our demand forecasting, which will feed into our resource plans. We can do the predictive models that we're putting in place. And I would just tell you, we did it in the past, but it was really cumbersome. It was really disjointed and not at the level of detail and granularity that we now can do. So it's been a game changer in that space. Yeah,
and to highlight, there were data science teams all over. They had spreadsheets, which I know no data scientists have spreadsheets, and disparate systems, desktops, what have you, third-party vendors, data flowing in, data flowing out. Just no, consistency. So getting them on Databricks, getting the MLOps, and creating those models on a modern stack, upskilling them, was huge. And they've done 3 models so far and have 6 more to do, and then more to come from there. Next is a database migration utility. So we developed a Gen AI LLM migration tool to take legacy data sources and migrate it on the Databricks using the power of an LLM. They have Teradata with over 30,000 objects. So what we did was we took one workload of 100 objects and ran it through our LLM on a Cloud 2 model. And we're able to do it with an 80% acceleration, where it automatically converts it to Python notebooks, does all the testing, and accelerates the whole thing. And also, part of that, when we run an analyzer on an install, it'll tell you the breakdown of the objects, simple, medium, complex, and shows an estimation of a manual effort. It came out to like 7.5 years to migrate all that. With our analyzer, we can get that down to 2 years. This is a 30,000 object, install. So pretty exciting stuff. They obviously have to get off before end of life, so we're going to be looking to do that here after we did that workload coming up.
So a quick show of hands in the room. Who here is from a California utility company? Or a customer? Anybody? Just a few? Okay. So I would say 4 of the biggest risks that we face at Xcel Energy is risks around nuclear, risks around our gas pipeline, risks around cyber, and then risks around wildfire. And I would say this will come across as a bit of a naive statement, but we at Xcel, I think, believe that we're a bit immune to the risk of wildfire, and we're not. And if you pay attention to the news, there was fires in Colorado, there were fires in the Panhandle, and all of those risks are critical for us to address. And so we are building a wildfire mitigation plan, and we are investing pretty significantly over the next several years into managing our wildfire strategy so that we can be predictive, we can be responsive, and we can be preventative. And all of those practices fall in place, will be successful through our UDP strategy. So all of that real-time data, the weather data, the even weather station data, satellite data, drone data, camera data, you name it, there's all this data that we have. We need to have all that data go somewhere and be able to take quick, actionable decisions off of that. And that's the strategy that we're driving with our Databricks implementation and our UDP.
Just to echo what Tom was saying, when you think about the wildfire risks and the data sets that we're using, you think about data products, the reusability, the scalability. I mean, what he just mentioned were like 3 different data sets that in the earlier one that I was talking about with energy forecasting and load and demand forecasting, same data sets. It's like right in previous, like 6 months ago, they were all independently being held, managed, and now we have centralized, we have certification around it. It really starts to show your value back to the investments that we're making.
I'll add one last thing that I really appreciate about Databricks is that, and of course Nousot, because they helped lead the way with a lot of this that we've done and that we've discussed with you today, is that, when it comes to wildfire, we were in a place of we had to radically prioritize. And there was a lot of questions around how are we going to do this? And we all, between Cindy and I, we maybe chuckled a bit and said, we've got you. We got it with Databricks, right? This is not going to be too difficult for us, and we know we've got the platform that can solution this. So that was a big. I think that's a great win for us.
So the last one, I'm just going to group a couple different examples together. We've talked about some very specific, but when you think about like the Gen AI trends over the last year, and we have had significant success in implementing those to help some of our business partners remove waste from their process, create more efficiencies, just new insights. Couple of them just to give you a flavor of beyond just like the traditional utility examples that you would think of, but that are more, cross industry. We built, Blake, who's in the audience here, built an investor relations dashboard with one of our other data scientists where we can look at all of our peers' earnings calls, analyze it within 15 minutes of their calls ending, and do a trend analysis, comparative sentiment analysis, everything else, give them, like they can do a Q&A against the question and answer and everything that the analyst asks. Another example is we have a twice a year survey that goes out to all of our employees. It gives our executives a way to look at the end of the year, 26,000 comments within a couple of days, and have, again, sentiment analysis against it, ask questions of it, use those Gen AI capabilities to really give us better insights, quicker insights. And then the last one, which ties a little bit into what Tom was talking about with the wildfire, we've got a lot of drone data. I mean, which is fine for inspections, but how do we use that again and again and again? So right now we're in the middle of building a multimodal model that looks and takes drone images, and then we can use that to figure out where we've got potential decay on our poles, and then use that to like where would we want to optimize and like our schedule systems and send our field crews out. So there's a vast opportunity. It's like, but it really comes down to setting that foundation and that whole tech stack maturity that we've been working on for the last couple of years.
So in the end, if not the end, but from the legacy platform to a scalable platform, they were able to develop a lot of assets to reuse across the enterprise, with automated onboarding, being able to get new sources on quicker, manage deployments, modernization with CI/CD, and a lot of the outcomes. Some good things we did there was rationalizing the intake management. Once Databricks was kind of out to the world that it was available, everybody in the company wanted to get onboarded. The compute is something you have to be pragmatic about and manage. So we created an intake cost calculator to understand the compute, breaking down all the Databricks services, whether it's batch or streaming or model serving or SQL warehouse. We're able to estimate that, forecast that, and manage it accordingly. And then we have to get more compute, we do. So that's been great for the organization. As you know, they're very cost conscious from capitalization and O&M expenses. And so that has to be very, very well managed. And it also just the acceleration of onboarding folks and the platform management, there's less shadow IT. So able to capitalize all that from that perspective. So what's next for Xcel Energy? Fully operationalized LLMs and taking the power of the new feature, the Gen AI data rooms or the Genie data rooms. We'll be able to, as we onboard all their data into the Unity catalog and make that discoverable, we can quickly stand up Genie data rooms and have, a ChatGPT interface where a non-technical person can ask a question and get quick, diagnostic and descriptive analytics and not require developers. And then, smart grid, hardening the grid, making more investments in those forecasting. From that regard, with wildfire mitigation, we're going to have that real-time data ingestion of all those wildfire settings, leveraging the other data from demand forecasting and creating those hybrid products as well. One other thing with the data rooms is, if you're familiar with the utilities, they have rate cases that they have to submit. We're going to create LLM over all their rate case data to be able to get better rate case outcomes and get better, obviously funding from that. And then modernization of the legacy systems. We'll be working to migrate their full Teradata install of the 30,000 objects. And another project we'll be looking at doing is we're ingesting all their log and user data so we can do cyber insider threat detection and do a bunch of anomaly detection so that we can get ahead of any type of threats to Xcel. Anything that I missed?
I think you hit it.
So last but not least, you're all invited. We have an event tonight at 8 o'clock, wind down. If you want to ask more questions about any of these use cases, we'd love to come talk to us there. Come on down, and we hope to see you all attend.
Thank you.
Very good. Well, good afternoon, everybody. It's great to see you all. It's great to see so many of you here from the energy industry. It's really exciting. My name is Dan Jeavons. I'm the VP for Digital Innovation at Shell. And with me is Bryce Bartmann, who's the Chief Digital Technology Advisor. And what we wanted to do is share with you a little bit of our journey together with Databricks to unlock data and AI for the energy sector. Maybe before I do that, I just wanted to say a huge thank you to Jeavons and the team. Huge congratulations on this event. It's a fantastic, really testament to the impact that Databricks is having on the industry. Before I go on, just please don't invest in Shell stock on the basis of what I'm about to say. I'm required to say that. But in all seriousness, moving on to the core content, we've been with Databricks a long time, and we've come a very long way in that time. When I first started working with Databricks was about 2014. They were a very small startup working hard on a very cool engine called Spark. And we saw big potential to leverage the massive parallel processing capability to accelerate our AI models at the time, particularly around some of the single-threaded challenges we were having with R, which seems a very long time ago right now. But that's where we started, and it was a really exciting time. And we saw the potential back then to unlock really data science at scale across the enterprise using cloud-based computing. Wind the clock forward a little bit. Of course, the emergence of Delta Lake as a standard open source framework for data storage, and then MLflow for model management really helped to turbocharge our adoption, because suddenly it wasn't just a compute framework, but it actually had some of the rudimentary tools of an emergent data platform. And we started at that point to really lean in with Databricks and to see how far we could scale this up across the enterprise. We were using it primarily as a data science platform, as I mentioned. By this stage, we were using both Python and R, but we accidentally stumbled across the fact that this could be a pretty good business intelligence platform as well, because it had a lot of the data that we needed already in the platform at that stage. And so we worked with Databricks to develop Databricks SQL. We also worked with them on Unity Catalog, Delta Lives tables, Delta sharing as well, to manage interfaces with third parties. And this has really kind of laid the foundation for what then happened, which is really a rollout of wall-to-wall Databricks as a foundational data platform across Shell. We use this pretty much everywhere today, across everything from retail through to subsurface. It's in trading, it's in R&D, it's in our asset management capabilities. And so it's very much become part of the fabric of our digital stack. More recently, I think it's been mentioned a few times today, we've been really starting to leverage some of the Gen AI and LLM capabilities. We have DBRX, which we're testing. We're also leveraging some of the model serving capabilities and also vector search. And so there's a lot of these capabilities which we're starting to take advantage of. I will say I think it's still early days for the Gen AI story, but we're very excited about what's to come. I think the thing that we're perhaps most excited about is that Databricks really creates a common data foundation for us across the enterprise. We have about 600 data scientists across Shell, north of 1,000 data engineers. The majority of these folks will have some level of interaction with Databricks as part of their day-to-day activities. So I thought what I would do is go a little bit deeper in a few of the examples of things that we're actually doing with the platform. And then I'm going to zoom in particularly on one specific area, which is time series data management, and some of the things that we've done to enable that. And then Bryce is going to talk through the architecture that we've developed with Databricks to accelerate our capabilities in that space. And then I'll kind of show you where we're going with a bit of a view of the future. So maybe start with the use cases. The first one is asset management. We have a very diverse asset base covering everything from energy and chemicals parks to offshore platforms to wind farms to solar parks to lubricant blending plants, you name it. And all of these things will generate large amounts of data. They typically, that is in the time series data format that comes from sensors directly feeding into IoT platforms. It comes from also things like historians, data capture systems, alarm and events databases, you name it, we have it. And so all of those different assets ultimately have a whole series of maintenance requirements. They have inspection requirements. They have optimization requirements. They need to meet emissions targets. And so having the ability to integrate all of that data into a common data plane and then run a combination of business intelligence and AI on top of that is extremely important for us. And we use this pretty much right across the patch. I'm not going to dwell on it too much because I'll talk more about some of the way in which we've done this in a few minutes. But maybe just before I do that, to broaden the aperture a little bit and talk about some of the other things that we're doing, we also have, over the last few years, been rolling out a common platform for R&D. So Shell has a huge research capability. We look at all sorts of different parts of the energy industry, from emerging technologies like direct air capture, right through to more conventional technologies like lubricants development. And so we've also found that not only is Databricks helpful in our assets, in terms of the operating assets, but it's also been helpful for our R&D. And we've integrated both lab sample data along with time series data from pilot plants, as well as also unstructured data, and brought that together into a common platform that underpins a lot of our R&D activities now. We're using this to do really cool things like accelerate the development of biofuels within conventional fuel blends. We've seen the cycle times reduced dramatically from about 24 to about 6 weeks using a combination of the data that we capture, but also computational science methods. But we're also now starting to embed unstructured data, which is helping our lubricants colleagues to accelerate the fuel development cycles for particular customers, and also silly use cases like finding historical tests that have been done on particular blends in the past and save us doing additional testing in external laboratories. So assets, R&D, equally important, and I'll give him a shout out. John will be giving a presentation on this later on in the week, so do go and see that. Increasingly, we're using this now in our power business and in our trading business, where we look at the development of optimization capabilities for future energy systems. That's often involving things like batteries and solar parks and wind farms and also conventional power systems. But it's also increasingly starting to integrate things like hydrogen electrolyzers. We're building the largest hydrogen electrolyzer in Europe right now, in the Netherlands. And the ability to integrate these novel energy sources into an integrated and optimized environment means that something like a Databricks platform for integration of all of these data sets into a common data plane is kind of foundational to be able to do this and to trade it effectively and optimize it accordingly. Last point I wanted to make is around measuring impact. Of course, for all of us in energy, and no doubt all of your companies are exactly the same, we have a constant challenge, which is we want to monitor the emissions associated with energy production and reduce and mitigate those things as much as we possibly can. This is true, of course, for CO2. It's also true for methane. And of course, methane is a very important topic, I think, for all of us, as gas is a transition fuel, but also can be a very potent greenhouse gas if it's not monitored and measured properly. So at Shell, we've set a target around being near zero in terms of methane emissions. And to do that, we've been rolling out surveys to ensure that we monitor our assets continuously. The challenge at the moment is continuous monitoring from satellites or from drone surveys is very difficult. That tends to be specific point solutions. And what we're looking to do is to develop real-time monitoring. So we've been partnering with Databricks to develop a real-time monitoring platform. We've made that available as open source. It's called PyELQ. You can find it on the Shell website. The idea is we want to be transparent in the way that we're developing our methane monitoring capabilities. We want to move those as much as we can towards real-time monitoring, and we're at the moment in the process of piloting that across several assets this year. So I could go on with a lot more use cases, but hopefully that just gives you a flavor of the wall-to-wall deployment that we have at Shell, the length of the engagement, and the scale that we've reached. One of the core projects in that intelligent assets section that I talked about has been the real-time data ingestion platform. And really this was born out of a problem, which was that we had a whole series of assets which had been built in over a variety of periods. As a result, many of these assets, as some of you will know, they have a variety of different systems in place. Some of them very old, some of them newer. But at the end of the day, it's very diverse. But actually, they have a lot of common problems. And in particular, one of the core problems is reliability. Being able to proactively technically monitor these assets at scale is really core to improving the overall reliability, profitability, and reducing emissions. And so we developed this platform, which we call the real-time data ingestion platform. The reason you can see the logo there is that it's now open source. We've open sourced it as part of the Linux Foundation for Energy. And it allows a capability to integrate all of these legacy assets and current assets into an integrated common data platform, which can process both historical and real-time process data. And it can effectively make that available through analytic applications, external applications, but also making it available for engineers and data scientists to work with. We've been integrating a variety of data sources into this platform. It's truly real time, very short lag. And we've been integrating, we started with time series data from historians and directly from the DCS systems. We've added alarms and videos. We've also integrated lab data, as I mentioned. And common sources are things like Pi, OPC-UA, and also other APIs that are coming from some of the DCS systems directly. So to give you a sense of where we've got to with this, this has actually been proven very popular. We invite you to go and download it and try it. It's no cost. It's designed to run natively on Databricks. So we built it out as truly open source. It can run in vanilla open source if you want it to. You can enable it with Delta Lake, with Spark, and so on. But you can also run it natively in the Databricks platform. It's got about 135,000 downloads a month, so a lot of people seem to like it. We in Shell use this in over 80 energy sites globally, so it's been proven to scale. We've got about 5 million sensors, sorry, that's an error on the slide, about 5 million sensors flowing through this every day, and it monitors north of 18,000 pieces of equipment every day. So it gives you a sense of the scale that we've reached, and this has really become the backbone for our intelligent assets strategy. I'm really delighted to say, and big thanks to Shiv and the team, that one of the things we've been working on is to make this available as a standard component in the data intelligence platform for energy. We're well on that journey. It's available now. You can download it and deploy it on Databricks, and we want to make it really easy to embed this into Databricks to help other companies with similar problems to us to scale these capabilities up. And so what I wanted to do was invite Bryce, who's actually the one who did all the hard work on this. I just talk about it. And invite Bryce to talk about the architecture that he's put together and how we're using it at Shell in a bit more detail. Bryce, over to you.
All right, thanks, Dan. Hi, all. It's great, really, to see so many people from the energy sector thinking about technology to solve their problems. And I think most of you who work in this part of the business, when you're thinking about data, are thinking about real-time data. If you're in, if you're in an oil and gas company, we have a lot of real-time data coming from our assets. It could be a manufacturing site, it could be an oil and gas rig. But if you're in the grid operator sector, it could be something like a substation. There's also, in all of our industries, we're deploying IoT devices that are streaming real-time data into the cloud. It might also be smart meters that are in your homes that are generating time series. It could be weather patterns and so on. Real-time data is actually a major part of the data kind of platform that you're going to be working with if you are in the energy sector. And at Shell, for us, it's been one of the biggest unlocks of value in terms of data for us. And we've been working on this in multiple iterations within Shell for over 5 years. And we've been trying to make sure that we built it in a way that it could scale just due to the size of Shell. And so on the screen, you can see there's probably architectures that you're very familiar with. You've got your data coming from your sources, and then you've normally got some sort of edge connector that is connecting to your source and pushing it to a broker in the cloud. Depending on the cloud that you're on, you're probably thinking about things like Azure IoT Hub or Kinesis in AWS, or you could just be using Kafka brokers from various providers. And you can also just be generating files or APIs that you're receiving the data from your providers that you're getting your data from. And then from there, a lot of you are probably taking that data, transforming it, and putting it into a lakehouse of some description if you're a Databricks customer or wherever that might be. And then from there, your end users start to consume it, or your applications. That could be BI analysts, it could be applications like digital twins. And we've seen at Shell a replication of this as we've scaled to different parts of the business. The same problem keeps coming up, which is that the time series data source is fairly different, but it all means the same thing at the end of the day. For me, time series data is really 3 key elements. It's the device that's generating it, the timestamp, and the value that it got. But we see that come through all sorts of different products in different formats. So we've been working to try and make sure that we could standardize and make a modular solution that can ingest data from these different data sources, put it in a common data model, and store it in Delta using Delta Live tables, if you'd like, or workflows. But then once it's in that common data model, then it starts to unlock the value where we can query it. So we've been building time series functions that probably a lot of you are used to in other types of time series data platforms, resampling, interpolation, time-weighted averages, and so on, and make that actually easily accessible for our consumers, Python developers, BI analysts, digital twins, data science applications, all actually using that data in whatever environment they may want to use it in, whether that is in a Databricks notebook, or it is in just their Python environment that they prefer to develop in, or in an application that wants to consume it. And so we use Databricks SQL, the serverless version, obviously, as much as we can because of the experience in terms of not having to wait for startups, has been really successful in our adoption, no matter where you're actually using it within Shell. And then we've also been doing a lot of work with Databricks Connect to try and make it easier to actually run Spark jobs from wherever that may be. With us, it's really important that we think Databricks running on the edge through Spark Connect is actually quite a cool way of doing it. So this is the architecture that we're building. We've got 2 kind of components that we call, one is called pipelines, which is your developers that are building pipelines, ingesting time series data, and then your queries are just your end users or applications that are reading from it. Like I said, it's all gone into Delta Lake. We spend a lot of time working with the Databricks folks on how we can improve time series. We do a ton of research on things like what does liquid clustering actually mean for time series? How does partitioning work? How does Databricks SQL improve in terms of how we can query all of that data? And we made it open source because these are tasks that really a lot of us are doing over and over and over again. And we think that we can be quicker by bringing this together in an open source package that we can use in the energy industry so that we can make the energy transition go quicker. So with that, Dan, I'm going to hand back to you on what we actually do with this data.
Thanks, Bryce. Amazing. So I wanted to give a bit of a vision of the future of kind of where are we going. I'm hoping that this is going to work. So one of the things that we've been trying to do, one of the use cases for this is making this available for remote monitoring. As I mentioned, reliability is one of the core challenges. And what we're trying to do here is globally create 2 centers, one in the US and the other in Bangalore, where I live. And we're making that available really to monitor all of our global asset base through an integrated common platform. That starts with the foundational layer that Bryce talked about, where we get all the data. But on top of that, we've built out a digital twin together with our partners at Kongsberg. We have about 33 of these twins across Shell. And that creates both a common, if you like, computer-based reality, along with the potential to create extended realities with things like HoloLens, where you can look at these assets, these physical assets remotely in real time, and also integrate the data. Of course, we're then adding capabilities like generative AI on top of that to allow us to query both the time series data, but also the data that's coming from documents, from also areas like, for example, different types of engineering data, alarms, events, and the like. And we're also embedding robotic data, so things like the camera, the video streaming off of those robots with machine vision overlays and integrating those into the twin. And what we see is that this is really bringing together the concept of the industrial metaverse at scale. It's allowing us to think very differently about how we're going to operate these sites in the future. And we're also doing simple things like digitalizing documents in a very, very different way using things like optical character recognition. So it's a really exciting time where we see that we're not only able to think very differently about the interactions between remote engineers and also engineers at the site, but as we move into areas like hydrogen and renewable power, assets which are much smaller in scale, assets which are often unmanned, assets which can go wrong very easily in some cases and can have reliability issues, and we've then got to be able to intervene accordingly. What we want to be able to do is make sure that we can intervene very rapidly. We can dispatch teams to solve those things, but by remote monitoring those things at scale, we're going to be able to operate that set of assets much more effectively and efficiently. So I think what I hope I convinced you of is, firstly, that Databricks is a foundational platform for us. It's scaled wall to wall across the enterprise. Secondly, we are learning from Databricks to develop open source frameworks for the energy industry. And thirdly, as we move into a low carbon future with a more diverse, more distributed, more complex energy system, we see that common data fabric is going to create a platform that's going to allow us to do things like remote monitoring at scale, also advanced forms of optimization, also improve reliability, and of course, monitoring emissions. And we find that really, really exciting. And I'll also say one final thing, which is we want to do this in an open ecosystem approach. We think that this is such a foundational problem for the energy sector that it makes sense to do it in an integrated and open source way. And we would invite you, anyone that's interested in working with us on some of these open source frameworks, do reach out. We're very open to talk more about what we're doing. So with that, huge thank you for having us. And we'll be around for a bit and happy to chat later on.
All right.
Sorry? Where's your presentation? I'm not sure. Is it email? Is it Google Slides? Is it PowerPoint? It's PowerPoint. It's PowerPoint. Colton, you said I'd have to drag it back, right? It's not this, right? No. Yeah, it's on. Excellent. 154. Next, nope.
Did you email it?
Yeah, Caitlin has it.
Oh, you emailed it.
Team shadows.
Isn't it?
Nope. Would be AVEVA.
Who's it from?
AVEVA?
I don't see it. What's it? This. It is this? Yeah.
There it is. Yep. Yep.
Right here.
That is perfect.
Okay, just building some anticipation here. Will the deck work or not? So, hello everybody. My name is Ronan de Hooge, and I'm Chief Software Architect at AVEVA. I'm happy here today to talk to you a little bit about our partnership with Databricks. So, first of all, who is AVEVA? AVEVA is a global leader in industrial software, and our mission is to connect our users with trusted information and insights that help spark their industrial ingenuity and help create a more sustainable future. So with over 20,000 industrial enterprises using our innovative products to deliver life's essentials, so water, power, pharmaceuticals, we're really fundamental, right? So, and in return, what we help these enterprises do is really collaborate and thrive in what is becoming an increasingly connected industrial economy, right? So, who's actually heard of AVEVA here? Can I see hands up? Actually, that's not bad. That's normally not what we see. So you might actually be familiar with AVEVA by some of the legacy brands or heritage brands we have here. So, but basically what AVEVA does is they create a portfolio of software packages, both on-prem and SaaS, that help our customers throughout the asset life cycle, the industrial asset life cycle. So on the design and build phase, you have projects or products such as Unified Engineering, or simulation products like Pro2 and SimCentral. On the operate side, you have SCADA control systems. Wonderware would be the big brand in that area, but we also have Indusoft, SciTech, Oasis, a lot of control pieces of software. And then last but not least, on the optimized side, you have the PI system, right? PI system founded about 50 years ago, just on the East Bay here, San Francisco, about 30 minutes across the bay by the late Dr. Pat Kennedy. And the one thing you'll see in common with all of these products or portfolio areas, it's really data that's tying these things together, right? So what we've done is we've created a platform that really helps unify these portfolio elements. And we're calling that Connect. But it's more than just unifying AVEVA products. Obviously, if that was the extent of the problem, it wouldn't be maybe as interesting as it could be. The idea here is really to open up this data to the broadest possible ecosystem, right? And that's kind of why we're here today talking with Databricks. And the former founder of OSI used to like to say, data is really the one asset in the world that the more it's used, the more valuable it becomes, right? And I really like that quote because that's really what we're here to talk about today. How do we get more eyes, more engineers, more data science using this data from these systems? So we really feel that AVEVA plus Databricks is really going to harken in this new era of industrial data, right? An era where we're harnessing data from the edge, from these systems that have been traditionally kind of in their use case on-prem, not siloed, but basically doing a very dedicated job, right? We want to accelerate the modeling and contextualizing of these different data sources to make sure they become more valuable by connecting them together. And we want to streamline the collaboration into an expanded user base. So traditionally, right, how this would have been solved is you build point-to-point connections, right? And there's a lot of this out there in the world at the moment, right? And there's nothing necessarily wrong with this, right? You have ETL operations that are copying data out of these on-prem dedicated systems and they're moving them up into Databricks or other Delta Lakes or data warehouse systems. But there are some challenges with this approach, and I think all of this audience will be familiar with some of those challenges. So what we've done is we've built a platform called Connect, right, that is helping with this. So it's not just really about moving the data either. You know, the first thing we're doing is we're evolving those on-prem systems to be what we call hybrid, right? So what does that mean, right? It means basically extending the footprint of those systems into the cloud. So creating new value, new use cases, new value for our customers through the cloud, but also bring some of that intelligence that's created in the cloud and bringing back into the domain of the operator where they actually live and do their work, right? You're never going to replace some of those on-prem systems, or I shouldn't say never, but not within any immediate future that we can all kind of see. You'll still have some of this footprint near your equipment because you have islanding requirements, right? But we also want to enable this cloud scale, right? If anybody's familiar with some of these systems, you know that really running a next generation AI or data workload against them isn't really how they were engineered. And some of these products, you know, they've been around the block a few times. So if you really strain them with a data load, you can see some negative performance characteristics in those softwares. And that really means that they're now starting to have an effect on the operators that are using them to run critical operations. So what the cloud enables us to do is basically scale to new use cases where it's appropriate, right? We're also adding contextualization. As we said, right, it's about unifying different areas of the portfolio, bringing in other data sources, creating a digital twin, a model around those things to make them more easily usable, right? And it's not just around our products or other data sources, it's also around supply chain. I think we heard this a couple of times already. It's about the ecosystem, right? If we look at the operating world of an industrial enterprise these days, or even as a software vendor, we exist in an ecosystem. We have partners like Databricks, right? Industrial operators have equipment manufacturers. There's data scientists. There's remote operators, specialists. Everybody that can help us get more value from data. And that's really the goal, right? Is we have these assets and data, and how do we make the most of them? And last but not least, we're integrating with Databricks, right? We're creating a very seamless mechanism to not copy an ETL data, but essentially expose a live view of that data into Databricks. So bring it all together. On the Connect side, we have this platform that we're building, and what it's really useful for is industrial applications. So we're pretty clear about where we see our value, and it's really when you do want to do domain-specific applications. You want to do control, right? You want to do simulation. You want to do things that are very much in the industrial context. But it's not the extent of the entire world we operate in, right? So you also have Databricks, bringing in a lot of rich data from across the enterprise, other sources, CRM, ERP data. And then we're enabling Delta Share to essentially allow the free movement of data across those boundaries where appropriate, basically enabling next generation applications and use cases. I'm starting to bang the drum here. More users, more use cases, more value. So a couple of customer stories. Probably going to sound a little bit familiar from what you heard earlier with Xcel and Shell, but I think we're all kind of seeing some of the same things, right? So Drax is a renewable power company in the UK, and what they do is they generate power from biomass pellets, right? So they create these pellets out of renewable sources like sawdust from wood mills or reclaimed wood from forests, and they create these biomass pellets and essentially they create energy from them, right? One of the problems they see is they get cloggages in the fuel lines for their generators, right? So what they want to do, they want to use data to predict when they need to take those units offline to do some maintenance, because an unexpected outage, a unit like this probably costs about £100,000 a day at least. So potentially huge losses with unexpected outages. So they tried this, right? They went down a traditional path and they extracted data from essentially a PI system. It took them about 30 minutes, I think, at minimum, to extract an initial data set, right? Took them, I think it was 6 to 10 different steps to cleanse and align that data to make it available to their data science team. And then they had an answer at one point in time, right? So what we did is we worked with the Drax team. We had them implement Connect, so we extended those PI systems up into the cloud so they were available, right? No cost, right, to doing that. And then we essentially helped them move that data into Databricks. And what they essentially now have is 10 times as much available within Databricks to do these analytics. And they actually have a near real-time model so they know when to take these units offline, right? So going from a very kind of project, one question workload to a continuous system. So a second example, again, very, very familiar, right? Mining company with lots of big, cool trucks, right? That's why we love mining companies. So they got these haul trucks. And one of the challenges they have, again, is big, expensive equipment, critical to operations. When it goes down, unexpectedly, huge issues within the production facility. So what they were able to do is they have, again, PI data that looks at fuel or it's actually fuel usage data, right? But it's not really enough to complete the story, right? So what they want to do is they bring that data up into Databricks, and they're also bringing in fleet management data, right? So they have a system that manages the fleet that knows what the trucks are doing when, right? And they have their maintenance data. And they're bringing that all into Databricks, creating a model, and now they know when to bring those trucks in for maintenance, when they're near essentially an area where it's appropriate to do that maintenance and when it's appropriate, right? So, and there's hundreds of these examples out there. Like, these are not unique in any way. I think the more interesting part is working with both of these customers. It really sparks ingenuity and innovation within these customers, because when they see how easy it is to do this, they have a second question nearly immediately. There's a second part that says, oh yeah, if we had this, we could do this next problem, right? It just really builds this energy internally where your data engineers are now spending more of their time thinking about problems instead of data plumbing and, oh God, now I gotta run another one of these jobs and that's gonna be painful, right? It just, as my friend Greg likes to say, lowers the marginal cost of curiosity. So now, I'm gonna give you a quick look at what we're building and how we expect this to work, right? So first, we're in our Connect platform, right? So these systems, on-prem Pi systems, Wonderware systems, everything we're kind of connected to has been deployed in a hybrid fashion. So the connections have been established and the data can move up. So one of the features within this tool, this platform, is to create essentially what we call curated data sets or data views, right? So your OT team knows that data. They know how to align it. They know some choices around cleansing it, contextualizing it, and they're now making it ready to be processed by a broader audience, right? Because there still is a lot of domain knowledge within that OT space about making the data basically appropriate for the types of operations you want to do within the data science space. So we create a virtual table. And that's essentially the terminology we're using for essentially this live integration we're doing with Delta sharing. So next, we provided just a couple of parameters, right? We talk about, do we want to interpolate the data, which means, time aligning it, or do we actually just want to provide the raw data? And there's no really right or wrong answer here. It's depending on what the use case might require. Either option is perfectly valid. And obviously, we let you choose how much history you want to expose. So next, we provide the MetaStore ID for the Unity catalog, right? Configure some security, right? So obviously, governance and security is very important around these operational data sets. They're very important around every data set, if you ask me, right? And that's basically it. Just a couple of clicks, and that table is now showing up in the Databricks workspace, right? So in this case, it's actually, I think it's a set of power data around a set of wind turbine assets. So basically, with no real coding, no real complexity, you've taken an OT curated data set and made it available to this tool chain, right? Just in a couple of clicks. So once it's obviously within the Databricks, everything's available within the Databricks space. So if you have a Python notebook here, we can run some aggregations on this data. Pretty straightforward stuff that you guys probably know a lot better than I do. And obviously, you can create or bring that data set into a Genie room, right? You can start asking natural language queries, getting to visualize and essentially process that data. So, parting messages, right? So this is very close. Like, I think I showed you a couple of customer examples. So some of this is actually available today. The Connect piece is definitely available. Actually, the movement into Databricks, it's a little bit manual at the moment, but that's something we're working on pretty actively with Shiv and the team right now. And we expect a much broader program open in Q3. So within the next couple of months, we'll be onboarding customers to do this live integration for real. Right? If you're interested, if this sounds interesting, please reach out to your AVEVA or your Databricks account team, and we'll be happy to kind of sign you up and see what you can get from this. So parting thought, again, Databricks and AVEVA, right? We're going to hearken in this new era for industrial data. We're going to unlock the value in that data sets. AVEVA obviously has a pretty large install base in the OT space. Databricks has got this giant potential everywhere else that we look, right? And we think the combination of the two can really bring a lot of value to you, our customers. Okay. Thank you, everyone.
All right, give it up for our awesome speakers today. So first up, Xcel Energy. Big round of applause for Tom Moore, Cindy Hoffman, and Giacomo. Shell, Dan Jeavons, Bryce Bartmann, thank you very much for walking us through our journey. And of course, Ronan from AVEVA. How exciting was that? The blending of OT and IT. We are here. This is a new era for industrial data and a new era for ingenuity in the industrial space. So excited about that. So up next, we're going to talk, we're going to have a little bit of a cozy chat. We're going to talk about future of energy. So my next guest up on stage is his last interview was a little bit tougher. Like, so I'm the nice guy here, right? Like his last interview was he was testifying in the US Congress on the impact of energy and AI and the intersection. I found that really, really interesting given the topics we are dealing with at this conference and the focus of our industry. So without further ado, let's welcome Sreedhar Sistu from Schneider Electric. All right, so we're gonna jump right into it. You can just pull up that slide if you want with his face on it because, yeah, there you go, easy. So just so that everybody pretty much knows me here, just this, thank you. Yeah, so everybody pretty much knows me here and I'm just asking decent questions, so not a big deal. But Sreedhar here, who's been gracious enough to join us. So Sreedhar, why don't you tell the crowd what are you responsible for, and why the hell were you in Congress of late?
I'm certainly hoping this audience would be much more easy on me. So for those who don't know, I'm Sreedhar Sistu from Schneider Electric, and so Schneider Electric and AVEVA are the same, that even though we play different roles. So Schneider Electric is one of the large industrial tech companies focusing on electricity distribution and the final consumption into everything that you do, and with a real focus on sustainability. Now, going back to your question, Shiv, what we have been doing at Schneider Electric in the past few years is looking at ways AI can help in the overall energy landscape, which is dramatically changing, both with new kinds of energy sources that are coming in, the grid transforming, and of course, there is a huge impact that data centers, the electric vehicles are going to have. And we have invested heavily in AI capabilities in addressing specifically this, which we know that we have to really take the first step in addressing it. And with that, I think last year was a time when Capitol Hill, there was a lot of activity on AI. Many of you know, lots of people from West Coast were asked to be there. And there was really an emphasis on the impact of AI on energy and then what AI can do to alleviate the challenges with respect to the energy system. So I had the privilege, to go and share some of the insights that we have learned over a period of time, and speak with our policymakers and ensuring that we get to make right policies on this really important and transformative technology.
Yeah, and I would agree the audience here is better than Capitol Hill for sure. So let's talk a little bit about that, right? So energy, like Mark Zuckerberg said this on a podcast, because that's where we get our news these days. He said that chips are no longer the scaling factor or like the bottleneck in scaling AI, it is energy. And so tell me more about like what are some of the areas that you are investing in at Schneider that impact the ability to really focus on a couple of things. One, how do you keep up with this demand? ChatGPT kind of changed everything and generative AI. How do you keep up with this demand for energy, particularly with AI and data centers being such a big focus? And how do you do it at the same time, keeping in mind the pillars of energy transition, right? We don't want to end up in a place where we end up consuming energy and not, we end up in a worse place than we were before. So tell me more, like, what are some of the initiatives that you're driving at Schneider Electric? What are you seeing in the marketplace? And what are some of the ways that you're applying AI to really combat some of these challenges?
Sure. So data centers is actually one of a very important segment for us, because data centers are the factories of the future. I mean, they are coming up everywhere. They are essential part of our day-to-day life. Everything that we have, streaming and video conferencing, everything requires data centers. And now you add to that, AI, not necessarily Apple intelligence. I mean, the whole artificial intelligence. There is going to be a tremendous impact on this. So, to put things in perspective, today we estimate that about the AI workloads contribute to about 4.3 gigawatts of energy consumption. Okay, and then we expect it to grow by 2028 at least 4 to 5 times. Okay, so between 15 and 20 gigawatts of energy that is required for specifically on the AI workloads. This is again a small percentage of the overall data center market that we see. Few interesting things about this, which is number one, data centers actually have been really good at managing the demand. They have been consistently getting efficient. So since 2010, there has not been a marked increase in the energy capacity that they needed. Especially when we see that there is the data usage and the data center usage has increased dramatically, right? So we expect this trend to continue. However, Gen AI has really put a big impact on the overall AI energy consumption. And the problem really is not that they are suddenly going to increase, double the capacity of the industry. It is not. I mean, at the end of the day, data centers are about 1 to 1.5% of the global energy consumption. So to put things in perspective, industry is consuming about a third of it. So it's pretty large, right? Now, the issue is that A, it is growing rapidly. B, it is really the places where you need to do it. I mean, it is not something that you can uniformly distribute. I mean, Virginia is where most of the data centers are. It's completely maxed out. And, you have to find ways to power those things. So we see this as an opportunity to introduce various measures to, cater to this, growing demand. And this is not different from how we see for the overall energy landscape, right? So 3 broad pillars. One is really reduce the energy consumption. So using AI, a way to reduce your total consumption. The second thing is how to integrate multiple energy resources into this and also time shift loads. So one of the biggest problems, and especially people from utility companies might know, is that this is the 6 p.m. problem, which is really when the peak of the energy demand comes up. Any forecasting that you do, 6 p.m. is when you have it. And the question is, how can we time shift these things so that we are not introducing peaks? Because peaker plants are the ones that are the most fossil fuel and most CO2 emission. And then the third one that we try to address is how to enable this transition, how to reduce the friction in adopting all these new measures, for customers, for contractors, for panel builders, all the people that are in this ecosystem, which is not an easy one. So these are kind of the 3 broad pillars. I'm sure there are other areas, but this is how we look at the energy system.
So you mentioned generative AI for a second there in terms of the impact on data and processing and data centers. So tell me more about you as Schneider Electric, what has been, obviously generative AI, a lot of hype. Has the tech sort of delivered the value that everybody is so hyped up about? How do you see it at Schneider?
So I don't want to be, the person coming and saying, it was not so good, but no.
I teed it up really well.
So first of all, I think it was really interesting moment, when, we had these LLMs. I mean, I've been, kind of be in the know since GPT, 1 and 2, trying to see what they can do. They were, widely inaccurate, but obviously launching the ChatGPT was a seminal moment. Not because, the technology changed dramatically in just a few months, but it had a fantastic interface, frictionless interface for everyone to experience the power of AI that people have been dreaming for 70 years, right? I mean, the artificial intelligence has been, the concept has been around 70 years, thinking machines, at the Dartmouth conference. So I think what we realized was that there is something in this that is important for us to harness, but I think it is also important to know what is the value that it is delivering. And this is also the fundamental of the way we apply AI at Schneider is to be driven by use cases that have an associated business value. I could be doing lots of science experiments, things that are really interesting, but then at the end of the day, they just end up in pilot hell, right? I mean, cool demos, everyone loves it, nothing ever gets into production. We took the approach that you have to be disciplined about this, and same thing with the Gen AI. we said that what are the use cases where we can really drive some value? And one of the first things, because it's natural language processing, it's been a hard problem for a long time for everyone. We found that, okay, there are many cases where we have lots of text information that can be made accessible to people through a convenient interface. So we came up with a whole set of use cases, and I can talk about some of those use cases, prioritize them and picked a few winners that we think that can really move the needle, and also things that are very, very important for our domain. So it's not just what you see, a chatbot that is smart, that I can read documents, etc., but what it can do in the industrial context.
Yeah, so tell us more about that. Like, just let's sprinkle some of the suspense out, right? So, what were the winning use cases in your space? Like, what did you say? Hey, this is something that's worth my time and energy and compute power, of course. Like, how did you go? Like, you went about this process. Like, which were the winning bets for you?
So the ones that we picked, we broadly categorized into two. One that is really helping our employees. I think this is for any large companies, people that's just, pretty well known. Things that you can do with, HR. I mean, HR information is notoriously difficult to find in the company. I mean, no matter how many SharePoint sites that you create, no matter how many documents you create, it's notoriously difficult to do that. So we found that as a first good area for people to access information, because everyone has to access HR at some point in time, and built in a process to ingest data, etc., that help them. And then that is going to extend to other functions. And by the way, we also have a full internal general purpose chatbot that's based on OpenAI, that is in a private tenant to have people do things that are not necessarily pre-scripted, like the HR and the finance. Then the other angle we took is what it can do for our own customers, okay? Because we operate in industrial domain, electrical domain, and some of the challenges here are we have some really unique things that we do. So one of the use cases that we recently demoed at Hanover Messa, I think you were there, Shiv, was about PLC code generation. So we all know GitHub Copilot, it can help you write Python code and whatnot. What about PLC? Because this is highly specialized code. And out of the box, these LLMs are not really capable of that. And we have lots of internal libraries that we have built over the years. And we can make the life of a PLC engineer much easier by providing a copilot that relies on these libraries. It knows how to create certain functions. And by the way, it can also do things that people don't want to do. Test creation, documentation, these are the things that no one wants to do. You want to write the PLC
Not
code.
Sexy stuff.
Exactly. So this is an area where we see having a unique differentiation, addressing our customers using GenAI.
That's super cool. And how successful, one of the things that I met Philippe and at Hanover, spent some time with him, one of the things that you guys are really passionate about is doing AI at scale. And what does that mean, for the average audience member here? Because that's one of the things that we talk a lot about at Databricks. Scale, right? And I do think it means different things to different people. How do you at Schneider define AI at scale? How do you think about that?
Yeah, great question. I mean, this is something that we've been thinking, for now roughly, 3 years or so when we started on this journey. So when we started to think about AI at scale, it's not that we are the first ones to do AI at Schneider. There have been lots of people who tried different things. There have been smaller applications built. And as you know, if we are a large company, there are lots of third-party companies that we work with. They are happy to build applications for us, so on and so forth. What we wanted to do was a few things. Number one, have a coherent way to approach AI, starting with why we are doing, okay? Is there an operating model for this? And is there a consistent way of delivering value? And we spent a lot of time thinking about how to do this, and there have been lots of models. I mean, you go to talk to Gartner, you go to talk to McKinsey, BCG, they've got, all kinds of different models.
A lot of pages printed.
Lots of papers printed on that. And it has to be contextual, right? It has to work in your company's context. So the model that we embarked on was, we said it has to be a hub and spoke model, which is a true partnership between people who know AI, who have specialization in AI, and then the people who know the business, whether it is customers or internal functions, etc. And it has to be a true marriage. And if one, drives away, AI drives away with the technology, then you know that it's a shiny object and finally nothing happens. And if it is purely left to people who are in business, you will get third-party vendors, you build something, and then after 2 years, who's going to maintain this application? Everyone is starting to look in the room. So we took the approach that it has to be a true hub and spoke model. We also have to have a consistent technology platform, okay? Because that's the way you can control it. Otherwise, it's kind of, all over creating tech debt. And Databricks is one of key components of our platform. And then having a rigorous process in place. And this is the hardest one, because it's easy to say that I have a process in place. How many of you have actually killed projects because it didn't have business value? Because it's really hard to do. You know that it's kind of nice, it's shiny, you want to keep going a little bit longer, but saying that, no, it's not working, let's stop it. So we even set ourselves KPIs to kill a certain number of projects every year. We know that it's wasted effort, but that's the only way that we can do. So, these are some of what I call as the highlights of how we embarked on AI at scale. And I think so far we've been pretty successful in spreading this message across the company and then putting things in production. To me, that's really the final measurement, that you put things in production, people use it. And by the way, my voice went up. If people are not using it, we should also be ready to kill it in production. It's not the end game. The end game is really value realization.
So I have a two-part question, maybe the last two today. How long have you been with Schneider? Let me ask you that first.
Over 4 years now.
4 years, okay. In the last 4 years in your AI journey, what has been the most impactful win for you in AI?
That's a tough one. I think I can see the impact from a couple of dimensions, right? So one dimension is really people adopting something that you build. That you don't have to promote it, you created it, and then it is working, and all of a sudden somebody is using it. So we have used, and we are again a complex organization. We build something centrally. Each country does things slightly differently, and all of a sudden I get a call from someone saying that they are deploying it in this country and they need some additional fine-tuning to be done on this model, etc. That's a great delight. The second one is really applying AI for sustainability. So this has been one of the key messages when we built the team, when we hired people, saying that, look, AI is a general purpose technology, not just GPT, the OG GPT. It's a general purpose technology, and you can do many things with it. And no offense, you can sell advertisements or whatever, or you can use it to solve some of real challenges that we face in the world today, and climate and energy are one of the important ones. So when this resonates with people, and you're also hiring people in their 20s coming out of colleges, and they see the benefit in that, that's really delightful.
That's fantastic. So now we're going to change the frame of reference, but the question remains the same. In the next 5 years, the most profound impact you think your team working on AI at scale in Schneider will make? What do you think your prediction is? Fill in the blank.
So I'm going to change the answer that I gave you before. We had a quick chat before this. I think the more I think about it, the most profound impact we will make with AI is in significantly reducing the carbon emissions. I think we strongly believe in the application of AI to this energy problem, and we can do it. And I think in 5 years, you're going to see the needle move and the impact it makes.
Fantastic. Couldn't have said it better. So it's decarbonization, decarbonization, decarbonization. Love it. Well, thank you, Sreedhar, for your time. I appreciate it. Big round of applause. All right, so that wraps up scheduled programming for today. All right, so just a quick reminder, everybody. There is a happy hour at the Industry Lounge at 4:40. All right, 4:40. We run the trains on time here. So 4:40 is what you need to remember. All right, so thank you very much for everybody in the audience. Thank you for joining us, and have a good rest of your conference.